Stoichiometry, the calculation of a product or reactant from another product or reactant in a chemical reaction. We're going to do for this reaction potassium chlorate decomposing to form potassium chloride and oxygen gas. So the triangle under the symbol represents that we're heating this. The MnO2 is a catalyst to help the reaction to occur. So we're starting off with a mass of potassium chlorate. We're trying to figure out how much oxygen we can produce from this. The solution map for a mass-to-mass stoichiometry problem is we have to turn the mass that we're starting off with into moles. We're dividing by that molar mass of potassium chlorate. Then we do the heart of all stoichiometry problems, which is the molar ratio, the stoichiometric ratio, the ratio of coefficients. So in this case, we're looking for oxygen, so it would be 3 moles of oxygen over the 2 moles of potassium chlorate that we're starting off with. So it's the ratio of what we're looking for over what we're starting off with, the coefficients from the balanced chemical equation. The final step, that will give us moles of oxygen. The final step is to convert that into the mass of oxygen by multiplying by its molar mass. So I normally set it up as a single reaction all the way across. And when doing this, it's good to use the compounds in addition to the units. So it's not just grams, it's grams of something. That way we can cancel things off. So grams of potassium chlorate divided by grams of potassium chlorate. Then we have moles of potassium chlorate divided by moles of potassium chlorate. Moles of oxygen divided by moles of oxygen. We're left with grams of oxygen for our answer. In a stepwise process, we take our mass of potassium chlorate divided by its molar mass to get the moles of potassium chlorate. The heart of the stoichiometry problem is this part here, converting moles of one compound into moles of another compound. This occurs in all of our stoichiometry problems, regardless of whether we're doing mass to mass, mass to gas, molarity. So we're taking our moles of our starting compound, the potassium chlorate, multiplying by the stoichiometric ratio. We have 3 moles of oxygen over 2 moles of potassium chlorate. So we're looking for oxygen, so it's on top. We're starting off with potassium chlorate, so it's on bottom. So this converts our moles of potassium chlorate into moles of oxygen. Once we have our moles of oxygen, we multiply it by its molar mass, 32 grams per mole, and we end up with 3.92 moles of oxygen. So it doesn't matter whether you do it as a stepwise process or a single whole reaction, single whole calculation. And we should get the same answer if we're canceling our units properly.